Let's talk about Cisco Stealthwatch and how you can use it to analyze your flow. Cisco Stealthwatch is the premier flow analyzer, and like we have discussed throughout this module, without proper analytics of flow, trying to find important information about the traffic on your network can be like trying to find a needle in the haystack. Stealthwatch will normalize your traffic and then begin to notice anomalies that occur. So, if you have a chatty network for your day-to-day business, no worries. That will be included in your baseline. Then, if there is a spike in traffic, Stealthwatch will be able to identify it, but maybe there isn't a huge increase in traffic, but rather a few new sessions being created. And if this traffic hasn't been seen before on this specific port, and especially for a new source and destination IP address, Stealthwatch will definitely generate another alert. Stealthwatch is even able to find malware and encrypted traffic without the need for decryption. Stealthwatch has its own concern index, and it uses machine learning to determine which anomalies could have the biggest impact. And if you wanted to, you could tie Stealthwatch to Cisco ICE or Active Directory, so that way you can correlate users to the traffic. This way, if there's an anomaly, you could quickly identify who is generating the traffic. This is especially helpful for insider attacks. Before, if someone had knowledge of the environment, they may be able to use that information to their advantage to bypass certain firewall rules or maybe jump from host to host in order to not be seen. But now, as long as there is network traffic, and the devices along the path to the traffic are configured to generate NetFlow and send it to Stealthwatch, then Stealthwatch will see the traffic, analyze it, and if it is concerning, generate an alert. As I mentioned earlier in this module, Stealthwatch can even be tied into other Cisco security products, such as PXGrid, like we talked about in the previous module. This information sharing can allow other security systems to automatically make decisions on whether or not this traffic should be allowed. If it shouldn't be allowed, it can automatically stop the traffic. Additionally, custom policies can be created, so even if the traffic that occurs is within the baseline, you can still be notified of it or have other systems take action on it. Of course, you can use Stealthwatch for forensics if an attack occurred and you want to investigate it. Or maybe there isn't anything malicious going on, but the executives in the organization want to see the reports on top users, top hosts, or just the overall traffic that is occurring on the network. Stealthwatch can be configured to generate reports so whoever needs the information can easily digest it. So, what are the components of Stealthwatch? First, there's the Stealthwatch Management Console, or SMC. This is the interface that you will be interfacing with. This is what actually analyzes all of the flow that is sent to Stealthwatch and creates the baseline and anomalies. This is where the reports will be run from and what you will use in order to actually see the traffic on your network. Then, there is a flow collector. This is the device that all routers, switches, firewalls, and anything else on the network that is generating NetFlow will send their flow to. The main purpose of the flow collector is to do just that, collect the flow. However, it can also ingest proxy records and then associate them with the flow records, which will allow for URL information as well as the user application to be associated with the flow, providing even more information. The benefit of having a flow collector in addition to SMC is that each device's resources can be dedicated to specific tasks. The flow collector is responsible for the aggregation of large amounts of flow, while the SMC is responsible for analyzing the flow. Both the SMC and flow collector are required in order for Stealthwatch to work. But there are two other components of Stealthwatch that, while not required, provide additional benefits. The first is the flow sensor. Flow sensors can be installed in order to generate flow for devices that cannot do it natively. When traffic is mirrored to the flow sensor, it then creates the telemetry data based off of that traffic. It even works for layer 2 traffic. The other component is a UDP director. The UDP director can aggregate all the flow data and then send it to Stealthwatch, but it can also send the data to other security devices. This is beneficial because even though Stealthwatch is very powerful, your company's security policy may require other devices to see the data as well. And as you saw in the previous clip, to determine where the flow will go, you need to use the flow exporter. If every device in the network had to send the flow to multiple locations, that could waste valuable CPU resources. Instead, you could configure all devices to forward the flow to the UDP director, which would then copy the data and send it to the necessary destinations, including Stealthwatch. Alright, that is everything that I wanted to teach you in this module. You first learned about what a flow is and how leveraging NetFlow will help you have a more secure network while also providing other benefits such as troubleshooting and helping identify traffic that needs engineered. Additionally, you learned the different versions of NetFlow and finally, some of the features and components of Cisco Stealthwatch. In the next module, we will begin our discussion on how to secure the management plane of our different networking devices.